Hey guys, what's up, people? Welcome to the session. We are back with a bang. We are here with the Sprint X series for Icse 10th. Yeah, people, finally it's here. I know that a lot of you guys have been asking me this for a long time. Sir, when is the Sprint X starting? And the answer is now. For physics, at least, it's going to be starting from today. We're going to start from force. We'll work our way through work, power, energy, and the rest of the chapters. I'll be giving you the entire schedule. It'll also be there in the community page, so do not forget to subscribe and check out the community page as well. My name is Anoop, and welcome to the Sprint X series, where we will be solving 10 very important questions from the previous board exams, and also from the previous year question papers, as well as some sample paper questions of basically the 10 very most important questions, the type of questions that you can expect in your board exams as well as your pre-boards. And let me know in the comment section, how are your preparations going, people? I really want to know what is it that you guys are doing right now. What are the steps that you guys have been have taken up in the past couple of days, once everything has gotten real right now, because CBSE's dates are out, and soon ICC dates will also be out. I know that a lot of you guys are anxious about it, but don't worry guys, it'll be out soon. But yes, let me know in the comment section, how are your preparations going, and what can we do to help you guys do better in your board exams? Let us know that in the comment section. So with that said, people, let's get into today's topic. We are going to be starting with the very famous Sprint X series. We'll start off with force. In this particular chapter, we'll be starting with torque and couple. So we'll be doing some problems and theory questions based on torque and couple, equilibrium and principle of moments, which is one of the most important topics. In fact, both these topics are equally important. Center of gravity, then uniform circular motion, and centripetal and centrifugal forces. Now again, let me remind you of this, people. We are not going to be going through the syllabus. I mean, we're not going to be going through the topic per se, because we've already done that in the Umang series. So make sure that you check out those videos. It'll be there somewhere. Just go out in the video section. You'll be able to find all those videos. But today, our focus will be on solving 10 very important problems of this chapter. So make sure that you have your pens and papers ready with you. Solve every single question with me as I'm doing it, and more importantly, let me know what is the answer in the comment section. Let's see how many of you guys are able to give the answer before I tell the answer. So make sure that when you're solving a question, pause the video and then solve the question for yourself. All right, so I hope you guys have accepted the challenge, because I want you guys to do so. So yeah, people, these are the schedules. So yeah, on 8th Feb, that is today, you'll be getting force. Work, power, energy will be on 9th Feb. Machines will be on 11th of Feb. Refraction of light at plane surfaces, session 1 would be on 12th of Feb. Refraction of light at plane surfaces, session 2 would be on 14th of Feb. Refraction through a lens would be on 15th of Feb. Spectrum would be on 17th of Feb. And all of these sessions would be happening exactly at 5 p.m. So make sure that you subscribe to the channel so that you're aware of it. Hit that bell notification so you're aware of it, right? Apart from that, on 18th of Feb, you have sound. Current electricity 1 and 2 would be coming on 20th and 21st. Household circuit on 23rd. Calorimetry on 24th, and radioactivity on 26th. All again at 5 p.m. So make sure that you have tuned in. Make sure that you hit the subscribe button. Make sure that you hit the bell icon as well. Be ready for that, right, people? And with that said, these are all the other schedules of biology we have, starting from 8th. Again, from today itself: cell cycle and cell division, a structure of chromosome, absorption of roots, transpiration, photosynthesis 1 and 2, circulatory system, excretory system, nervous system 1 and 2, as well as endocrine system, and done by our very own Ambika ma'am. Then we have for chemistry by our very own Anoop ma'am. Periodic properties and variation, chemical bonding, study of acid, base and salt 1 and 2, analytic chemistry, mole chemistry and stoichiometry, electrolysis 1 and 2, and then metallurgy, compound, study of compounds 1 and 2, organic chemistry 1 and 2. Again at 6 p.m. You who know the dates, people, you can download the notes. So don't worry about it. You can download the notes. It'll also be in the community page. So don't worry. The schedule will be available to you. Make sure you're here every single day at this prescribed time, so that you don't miss out on anything that is important, right? So English is so and so forth. Merchant of Venice, 4 sessions. The Heart of the Tree, The Cold Winton, the Bangle Seller, After Blehen. I hope I'm pronouncing it right. Television by Shweta ma'am, by the way. Daffodils, The Patriot, 9 gold medals, Chief, Seattle's Speech, Old man at the bridge, a horse and two goats and hearts and lands on it. Good luck with that. And then we have okay, there's a lot more. Face of the Dark, an angel in disguise, the little match girl, my greatest Olympic prize. Then we have SST by Ankana ma'am, the Indian national movement, 3 sessions, the mass phase of the national movement. Okay, guys, you get the point, people. There's a lot of topics. So yeah, this itself will take me one full day. So yeah, you have a lot of topics. Math starting with GST, going all the way till mensuration, starting from 8th itself. So all of the topics, all of the chapters, all of the important subjects, we're going to be starting from today itself. So make sure that you subscribe to the channel. More importantly, do it with us, because we are doing this for you people, to make you guys better, feel more confident, and more importantly, to understand what type of questions you can expect from your board exam and pre-boards. Alright, so with that said, people, let's begin the 2021. Subscribe to the channel, by the way, hit that like button, and yes, this is the quote that we're going to start off with. Dream big, stay focused, and make it happen. Simple. So whatever your goal is, if you want to score 70%, make it 90%. If you want to score 90%, make it 99%. Dream big and stay focused. And yes, people, if you put in the effort, there's no one who says that you can't, you don't deserve it, or you can't make it, right? It's up to you. So make sure that you don't lose that focus. Right, guys, let's begin. The first question of the lot. Here we go. First chapter. The question is this. This is a question taken from board exams, your 2017 boards to be more precise. It's a 2-mark question. In your board exams, you can take up to 2 to 3 minutes, but here we're going to solve it in 1 minute. So the question is this. A brass ball is hanging from a stiff cotton thread. Draw a neat label diagram showing the forces acting on the brass ball and the cotton thread. Such a silly question, such a simple question, not silly, but simple question. 2 mark in your pockets. Let's go, guys. It's a very, very simple question. So all you're gonna do is basically draw a rigid structure. This would be your rigid structure, or the the wall that you're fixing it on. This is the thread, and this is the cotton ball. So what are the forces? The weight of the ball would be acting downwards. The force of gravitation is acting downward. That is nothing but the weight, and the tension on the string. Because of the weight, there'll be a tension created, and the tension would be opposite, to the weight. So this would be the answer for this question. I don't think I took 1 minute also to solve this question, but yeah, people, that is the answer. That will be the support of the rigid structure. Tension would be in the upward direction. Weight would be in the downward direction. 2 mark questions. 2 to 3 minutes. I don't think it's needed at all. But 2 mark board exam question, guys. Make sure that you not remember it because you know it, but make sure that you don't get it wrong. Second question. Here's another one from 2017 boards itself. The question is, the distance between 2 bodies is doubled. How is the magnitude of gravitational force between them affected? Wow, people. What a brilliant and difficult question. 2 mark question. Exams, you get 2 to 3 marks, 2 to 3 minutes to solve this. Sprint time is 1 minute. Let's go, people. Is a doubled half becomes 1 by 4th, or becomes what? 4 times. Let's go ahead and solve this, people. Remember the formula. F is equal to GMM by R square is the formula. So F is indirectly proportional to R square. So if R becomes twice, basically R becomes 2R, then what will happen to the force? It will be 4R square. In other words, it will become 1 by 4th of the force. So whatever is the initial force, it'll be 1 by 4th of that initial force. So that will be the answer, people. So it'll be 1 by 4th. That would be definitely the answer. I hope you guys got this. Come on, guys. Do not forget all of these simple, silly things. Again, it's a 2 mark question. 2 mark, easy 2 mark in your pockets. Why to lose it, right? Why to lose it? F is equal to Gmm by R square is a formula where F is nothing but the force of gravitation. G is nothing but the universal gravitational constant, 6.67 into 10 to the power minus 11 meter square per kg. Then mm is nothing but the mass of the first body. Second m is the mass of the second body, and r is the distance between the 2 centers of those 2 bodies. Right, that's it. 2 more questions in your pocket. So because 1 by 4th is the answer. Moving on to the third question, again from 2017 board exam itself. So many questions from 2017 question. Here's the question. Again, it's a 2 mark question. Time in your exam is given. You can take up to 2 to 3 minutes, but sprint time 1 minute is. Here we go. Why is a jack screw provided with a long arm? Why? Because people, you know the answer. Let me know what is the answer in the chat box right now, because you know the formula, guys. torque is equal to force into the distance, the perpendicular distance. You can take it as d or r, it's totally up to you. Now the greater the distance, the more would be the turning effect. It's directly proportional towards basically the torque is directly proportional to r. So if you increase the distance, what would happen? The torque would also be greater. So that means that the effort needed is going to be much more lesser, or for the same effort you'll be getting much more moment of force or much more turning effect or much more torque. And that's why you have a much more longer arm in the case of a jack screw. 2-mark question, guys. Easy 2-mark question. So just write the theory that write in bullet points. That'll be better. So write on the formula first. Show the teacher that you know the answer. You know why you chose that answer, why you gave that answer, because torque is directly proportional to the radius or the perpendicular distance. So more the distance or more the radius, the more the turning effect, or in other words you can write as torque or moment of force, whatever word you're comfortable with, turning effect or torque or moment of force. All right, so that is the answer for this question. 2-mark, 1 minute time, that will be the answer, people. You can download the notes again. So that's the more the distance from the point of application of the force, more will be the torque produced on the jack screw, and thus it's more easy to rotate. Sorry about that. So it'll be much more easy to rotate. So for the same effort, you'll be getting more turning effect, and that is why you're given a longer arm for that, right? Moving on to the next question. The fourth question, again from 2017 board exams. Some 2017, some sort of we have some sort of deal, I believe. All right, 2-mark question. Time in exams you can take up to 2 to 3 minutes, but it's sprint X, people. 1 minute. Let's go. A uniform half-meter scale, half-meter rule balances horizontally on a knife edge at 29 centimeter mark when a weight of 20 GF or gram force is suspended from one end. Draw a diagram of the arrangement and what is the weight of the half-meter rule. Your options are 120 GF gram force, 150 gram force, 105 gram force, or 110 gram force. Pause the video, solve it with me. All right, I want you to, okay, I got all excited, but yeah, we will solve the question with me. Let me just do it. First of all, I'll draw the meter scale. So if this is the meter scale, basically the weight would be exactly in the middle. So it's a 50 meter, it's a half-meter rule. Half meter means 50 centimeter, so it'll be somewhere over here. This would be where the weight would be acting. That will be X. So weight would be at 25 centimeter, obviously, because it's exactly in the middle, so it'll be 25 centimeter, and it's balanced at 29 centimeter. This distance is 29 centimeter. All right, and there's a weight acting which is of 20 gram force acting at the edge. This is the diagram, so you can draw the diagram this way. Mention again, you can mention that this whole distance is 50 centimeter. Mention that this is 25 centimeter, 29 centimeter, and that is exactly at 50 centimeter. Now that itself, I believe, took me to explain it took me about 30 seconds. Now, what is the weight of the half-meter screw? Now, the point is very simple, guys. If you remember principle of moment, clockwise moment should be equal to anti-clockwise moment. That's all, right? That is the simple formula. So how do you find the clockwise moment? Clockwise moment is what? 20 into what is the distance? This is at 50 centimeter. So you have to take the distance from the center to this distance. So 20. So what is the distance? This distance would be what? This distance is 29 or 50 minus 29, which is nothing but 21. Why 50 minus 29? Because the weight or the weight is balanced at 15 centimeter mark. So from the center, what is the distance? It will be 21 centimeter. So this distance is 21 centimeter. So it will be 21. And what is this distance from the middle? From the middle of the scale to this, where the scale is balanced, this is 4 centimeter, because it's 29 minus 25, which is nothing but 4. So is equal to, what is the clockwise moment? It's anti-clockwise moment is nothing but X, which is nothing but the weight of the scale into the distance 4. So 20 into 21 is what? 240 is equal to 4x. So X is equal to 420 divided by 4, 414, so it'll be 105 kgf GF, because TF, because it's gram force, right? So I believe I took a little longer than 1 minute. For sure I took longer than 1 minute because I was explaining the steps. But if you're doing it, guys, it's a 4-step problem. Now 4 step, not even 4 steps. Aram say you can do it in 3 steps also. 3-step problem. This is, guys, that is how long it would take. So it's a 2-mark question once again, which in your exams, if you want, you can take 2 to 3 minutes, but you don't need 2 to 3 minutes. That's what I'm trying to prove here. You can do it in 1 minute time. If you are not explaining it to someone, you could do it actually in 1 minute, right? So that is the answer, guys. Just draw a diagram first and then go ahead and solve for, use the principle of moment or the formula and solve it. That's it, guys. So this will be the answer. The weight of it would be 105 GF, gram force. If you want to convert it to kgf divided by 1000, so it'll be 0.105 kgf. But here the answer is given in GF itself, so you can leave it as GF. Now again, guys, I know GF. I know a lot of you guys, all the guys watching, they don't get the wrong ideas, people. This is a sanctuary. Here's the 5th question again. Board exam 2013 wala question. 2-mark question. Time in exams can be about 2 to 3 minutes, but sprint time is 1 minute. Your question is, where is the center of gravity of a uniform ring situated? The position of the center of gravity of a body remains unchanged even when the body is deformed. State whether the statement is true or false. It's a 30-second question. 30-second. First part of the question. Where is the center of gravity of the uniform ring situated? At the center itself. At the center of the ring. At the center of the ring. Obviously, because if it's a circle, the center would be the center of gravity as well. The geometric center of the circle or of that ring would be the center of gravity. So you can write it as the geometric center or the center of the ring itself. For the second part of the question, is it true? Okay, the question is it true if the position of the center of gravity of a body would remain unchanged even when the body is deformed? The answer is false, because when the body's shape would deform, obviously the center of gravity would also change. It will not remain the same, people, because your center of gravity depends on the shape as well. So if the shape gets deformed, like if imagine you have a ring and you crush that ring, do you think the center of gravity will still be the center of that particular ring itself? No, it will not be, because it's deformed. So obviously that's not going to be the case. That's a 30-second question. 30-second, hardly. That is to think into right, it'll take 30 seconds. So that's it, people. That's a 2-mark question once again. So all this while we've done 5 questions, all of 2-mark each, which means that 10 marks, 5 minutes, 10 marks is in your hands, guys. That's how easy it is. So do not panic. Understand that these questions were also created by humans for humans, and you don't need an extraordinary memory or brain to solve these questions. Trust me, all right? Trust me, that's not needed. It's just practice. Practice as many as you can. Do as many questions as you can. Make sure that you put in your 100%. It does not matter whether someone else thinks that you have to sit for 4 hours or 6 hours. It's not up to them, it's up to you. Make sure that you spend whatever time you need to make it happen. This is all I have to say. All right. Now, people, if you are enjoying the session and you want more help from us, if you want to, be a part of us, learn from the best of the best teachers, gain 100% knowledge, and get access to unlimited sessions just like this one, have a lot of fun and do a lot of quizzes, click on the link that is given in the description as well as in the pinned comment section. Now, before you click on the link, let me tell you why Vedantu is so widespread. It's spreading like a wildfire. Why is that? First of all, guys, you have the opportunity to attend unlimited live session. There is no limit as to how many sessions you can attend in a day. It's totally up to you, people. And all of those sessions, trust me, will be fun-filled because it will be very interactive. It's not going to be a one-way conversation. It will be very, very interactive. You guys know about it. All those who are already a part of it, you know about it. With that, guys, you have the ultimate experience of doing lots of fun quizzes as well. Highest level of quizzes which will help you to push your boundaries and make yourself better every single session, every single day. And those quizzes, guys, will help you to compete with the rest of the world and see how good you are in that particular subject. With that, even if you miss out a session, don't worry, you can still take the quiz once the class is done and still check out the leaderboard once while you're watching the replay sessions as well. So you never ever have to worry about missing the quiz questions or practicing the same kind of questions over and over again to make yourself better. And yes, people, you can download all the premium content, all the handwritten notes, all the recordings of every single session, so you never ever miss out on anything that is important. Everything that is needed would be right there in your fingertips. With this, I would say this is probably one of the best features at Vedantu, that you don't have just one teacher to help you solve your doubts and help you understand the concept. No. With the master teacher, you will also have the class teacher to help you clear every single doubt. The class teacher's job is to make sure that you walk out of the class without any sort of doubts. Even if it's 100, 200 doubts in the same class itself, it does not matter. All of your doubts, or each and every one of your doubts, will be cleared inside the session itself. And yes, people, I know that you guys are panicking right now. You're looking for tests and assignments to make sure that you're making yourself better every day. You don't have to go anywhere for that as well. You have quality number of tests and assignments, and these tests and assignments, we have the best of the best questions allotted for you guys, with questions taken from previous year question paper, from sample papers, from your ISOs. For the best of the best questions are taken to test your very own limit. That's what we are here for, people. And with that, guys, I would say a cherry on top of your ice cream with all of these 5,000 plus micro courses and crash courses, all for free. Link is given in the description as well as in the pinned comment section. My coupon code to avail the discount is AME Pro. Let me tell you what the discount price is. So if you go for the 1 month program, people, the base price of that is 2,699 rupees, which is a lot of money. I understand that. But if you use the coupon code AME Pro, you get a flat discount of 500 rupees, and the price drops into 2,159 rupees. And more importantly, guys, this, if you think about it, in terms of the value for money that you're getting, you have ultimate value for money over here, because for that 2,159 rupees, you would have attended about 200 sessions roughly, all right? Roughly about 200 sessions. That means that per session, you're paying about 11 rupees. Ultimate value for money, which is less than what you pay for a packet of Lays, which costs you 20 rupees, has 80% nitrogen in it, and lasts for 10 minutes, maybe less than that, right? So again, value for money, and the best of the best teachers on the best of the best platform. Link is given in the description as well in the pinned comment section. The coupon code is AME Pro to avail your discounts. So go ahead. What are you waiting for? Alright guys, well that's it. Let's get back to the question. Sixth question, 2015 board exam, 3-mark question. So now we are, taking it up a notch. 3-mark question, 3 to 5 minutes, but here we're going to solve it in 2 minutes time. The question is this. Read the question carefully, pause the video if you have to read it carefully. The question is, two forces, each of 5 Newton, act vertically upwards and downwards respectively. Sorry about that, a little thirsty, right? So yeah, two forces, each of 5 Newton, acting vertically upwards and downwards respectively, on two ends of a uniform meter scale, which is placed at its null point as shown in the diagram. Determine the magnitude of the resultant moment of these forces about the midpoint. Go ahead, guys. Let me know what is the answer in the chat box. Let's see how many of you are able to give the right answer. Your options are 5 Newton meter in clockwise direction, 5 Newton meter in anti-clockwise direction, 0.5 Newton meter in clockwise direction, or 0.05 Newton meter in anti-clockwise direction. Sorry for that as well. Alright, so it's a 5 Newton force. Both of these are 5 Newton itself. The scale is balanced at 50 centimeter mark. You're supposed to find out what would be the resultant, the magnitude of the resultant moment of these two forces. Alright, so how do you calculate the magnitude of resultant force? First of all, what is the clockwise? So we'll calculate the clockwise moment first. Alright, the clockwise moment. Clockwise moment is what? Is going to be, what is the formula for moment? It's nothing but tau is equal to force into the perpendicular distance. Force is nothing but 5 Newton. Now the perpendicular distance from the midpoint is 50 centimeter. This distance is also 50 centimeter. This distance is also 50 centimeter itself from the midpoint, because it's a 100 centimeter long scale. Now the question is, guys, now look at the unit. They've given it as Newton meter. So convert that 50 centimeter to meter. So what will that be? It will be 0.0 5 meter, because 50 centimeter divided by 100 is if you have to convert to meter, so it'll be 0.5 meter. That will be equal to what? 2.5 newton meter. 2.5 newton meter. Now, to find out the anti-clockwise moment, what would be the formula? Once again, force into perpendicular distance. Force is 5 newton. So anti-clockwise moment is nothing but this one. This is the clockwise moment, and that will be what? 50. Again, once again, it's 5 into 0.5 itself, which is nothing but 0.5 newton meter. Again, the distance is also the same, so it means 2.5 newton meter itself. So what is the moment, the resultant moment acting above the point? So I'll take this as tau 1 and I'll take this as tau 2. So the resultant moment will be tau is equal to tau 1 plus tau 2, or torque 1 plus torque 2, which is nothing but 2.5 plus 2.5, which is nothing but 5 newton meter. In what direction? It will be in what? It will be in anti-clockwise direction, because it's going this way, and anti-clockwise direction is going to be positive itself, so it will be plus 5 newton meter in anti-clockwise direction. So that would be the answer, people. So here it is, once again, force into the perpendicular distance, so anti-clockwise, and both of these are anti-clockwise itself. So yeah, by the way, I wrote here as clockwise and anti-clockwise. We'll just take it as clockwise itself. So both will consider it as anti-clockwise, not clockwise, because yeah, I took one as clockwise. Generally we take one side as clockwise, the other side as anti-clockwise. No, this basically, you can use the formula of couple itself. Here it's nothing, it's creating a couple force. So you can, if you remember the formula of couple, it's nothing but force into the distance between both the forces acting. So the total distance is nothing but 100 centimeters. So 5 into, so either one of the forces into the perpendicular distance between the two forces, that is the formula. So you can directly use the couple formula, which will be 5 into 100. Now again, 100 centimeter is what you get, so divided by 100, so it'll be 1 meter, so it'll be 5 newton meter itself, right? So you can either use that, or you can go ahead with this one and find out the answer for this one like that as well. All right, so it's totally up to you guys, but yeah, ultimately you'll get the same answer. Again, 2 minutes time, it'll take less than that if you go with the couple wala formula. It'll hardly take you 30 seconds, but if you go with this one, if you want to calculate it manually, that is, calculate the moment about the first one and the moment about the, so instead of writing as clockwise and anti-clockwise, write it as moment about 5 newton and moment about 5 newton on the other side. So mark it as A and B and do it this way. You can do it that way as well. So what I'm trying to do is to, when you're writing the answer also, you can write it this way. So you take it as A and B and solve it accordingly. So write moment about A and moment about B and add it up. Right, so that's it, guys. So that is the answer to this question. Yeah, that would be the end of the 6th question. 3 more question, which we did in less than 30 seconds. And if you talk about the couple formula, if you go about this one, it'll hardly take you 2 minutes again. All right, next one. 3 more question taken from 2018 board exam. In your exams, you can take up to 3 to 5 minutes, but in the sprint time, because it's sprint text, you'll have to solve it in 2 minutes. The question is, a half-meter rod is pivoted at the center with 2 weights of 20 GF and 12 GF suspended at a perpendicular distance of 6 centimeter and 10 centimeter from a pivot, respectively, as shown below. So you can see the diagram over here. Which of the two forces acting on the rigid rod causes a clockwise moment? Is the rod in equilibrium? The direction of 20 GF, not kgf, will be GF force itself. GF force is reversed. What is the magnitude of the resultant moment of forces on the rod? Whoa, got a little serious now. All right, so this is the question, people. The diagram is clearly given. It's such an easy question. In fact, for the first part of the question, let's answer the first part of the question. Which of the two forces acting on the rigid rod cause the clockwise moment? This is clockwise. This is causing anti-clockwise moment. So 12 GF would be the one causing the clockwise movement. Clockwise moment, not movement. Clockwise moment, right? So that is the first part of the question. Second part of the question. Is the rod in equilibrium? How will we find that out? Clockwise moment should be equal to anti-clockwise moment. So clockwise moment is what? We'll take it as 12 into the perpendicular distance, nothing but 10 centimeter. So again, if you want to keep it a centimeter, it's perfectly fine. Just leave it like that itself. There's no need for you to convert, because they have not given it in terms of Newton meter or something. They've taken it as in terms of gram force. So you can just leave it like that. So it'll be 10 is equal to anti-clockwise moment is nothing but 20 into 6. So clockwise moment, this force into the perpendicular distance is the clockwise moment. This force into this particular distance is the anti-clockwise movement. So that is nothing but 20 into 6. So 12 into 10 is 120, which is equal to 2 into 6 is also 120. So it's 120 is equal to 120. So yes, they are in equilibrium. They are in equilibrium itself. Third part of the question. The direction of 20 kg or 20 gram force, if it is reversed, what would be the magnitude of the resultant force? If you were to, turn it around, like if you were to keep it on this side, what would happen to the moment? That is what they're asking over here. Quite simple, people. Again, add it up. So it'll be 20 into 6. 20 into 6 plus 12 into 10. So that will be 120 plus 120, which is nothing but 240 gram force. Centimeter. Gram force, centimeter would be the answer for this particular question. So that is it, people. That would be your solution. So that'll be 240. You have to mention the, don't forget to mention the unit, guys. It'll be gram force centimeter. That would be the answer for the 7th question. I hope you guys got it so far. Are you guys enjoying, people? I know it's simple questions, but still, if you guys are doing it right, that means that you are prepared for it. So make sure that you get this question right. I don't think it even took us 2 minutes to solve this question. It took us 1.5 minutes probably. So yeah, guys, that would be the answer for this question. Do not forget to hit the like button, and more importantly, do not forget to subscribe to the channel, because we're coming with a lot of Sprint X series. So make sure that you're subscribed to it. All right, 7th question. Let's go. 2013 board exam, back to the same old 2013. So many questions we took from this particular topic. 3-mark question. Time in the exam is from 3 to 5 minutes, but guess what? It's Sprint X, so 2 minutes. That's all. Go ahead and do this. The question is: give any two effects of a force on a rigid, non-rigid body. One end of a spring is kept fixed while the other end is stretched by a force as shown in the diagram. The force is this way, I believe. It'll be this direction, right? And yes, copy the diagram and mark on it the direction of the restoring force, and name one instrument which works on the above principle. Whoa, 3-mark question. Let's go ahead and solve this, guys. Give any two effects of a force on a non-rigid body. So what are the things that force can bring about, or what are the changes that force can bring about? It can change. First of all, I can say that it can change the shape of the body. Okay, let me just write the entire statement. Let me just write it over here, guys. So first part of the question is, it can change the shape and size, because force, when you apply force to a particular body, which is a non-rigid body, it can change the shape and size of that particular body. Secondly, you can also say that it can change the state of motion. It can change the state of motion. If it's in the state of rest, it can change it to state of it can bring about the change in state of rest to motion. If it's already moving, it's already in motion, it can also bring the body to a state of rest. So change in state of motion is also one more change that it can bring about. Now, to answer the second part of the question, if one end of the spring is fixed as shown in the diagram, copy the diagram first. So I'm going to make the diagram over here. This is the fixed surface. This will be your spring, right? This is where the force is acting. In which direction would be the restoring force? The restoring force would be in the opposite direction. So F restoration or restoring force would be in the opposite direction to the force that you're applying. Because what is restoring force? It's trying to bring it back to its original state. It's like a rubber band. When you expand the rubber band in the opposite direction, the rubber band is always trying to bring it back to its original state, right? So here also, when you're trying to pull that spring, it's already fixed to a surface. When you're trying to pull it, it's trying to bring it back to its original state. In other words, your spring constant, we call it as. So that is nothing but, it's going to be in the opposite direction. So F restoring would be the opposite direction. Name one. So this is the second question. So you can draw the diagram over here. So this would be your second part of the question. Third part of the question is, name one instrument which works on the above principle. Guess what, people? In the chat box, let me know what is that instrument that it works on. I'll give you a clue. It is used for measuring the force acting on a body. Anyone? It'll be your spring what? Your spring what? Let me know what is the answer, guys. If you talk about your the to measure the force we use called as a spring balance. So spring balance also works on that. I was not able to get the last word, so yeah, spring balance is what it works on. So spring balance basically works on the same principle. So you for example, you have a hook at the end of it, so you hang it onto the hook, and it tells you what is the force, or in other words the weight, that is, or yeah, you can call it as a force. It's the force by which the force that is acting on that body, the force by which anything is getting pulled, all of that can be measured by using a spring balance. So that would be the answer for the next part of the question. That's it, people. Eighth question done. 3 mark question, and again 2 minutes though, too much for you people. It's like, yeah, aram se do it though, but the board exams, take your time and do it. Don't rush into it, people, so make sure that you do it. Okay, so now this question. Okay, first of all, the ninth question is, define what is 1 not kg, what is 1 kgf. A boy of mass 30 kg sitting at a distance of 2 meters from the middle of a seesaw. Where should a boy of mass 40 kg sit so as to balance the seesaw? Or a third part of the question is, what is meant by the term moment of force? And in that subsection, if the moment of force is assigned a negative value, then what will be the turning tendency of the force? Will it be clockwise or anti-clockwise? 2012 board exam paper, this question was asked. 5 mark question. You can take up to 5 to 8 minutes to solve it, but it's sprint time. 3 minutes was what you get. So first part of the question is, let's solve it. Come on. Define what is 1 kgf. 1 kgf is nothing but 1 kgf is nothing but the force by which earth pulls the earth pull. Okay, I know my handwriting is very untidy, but don't worry guys, you can download the notes. The printed one will be there, so don't worry about it. 1 kgf is the force by which earth pulls a body of 1 kg towards itself or towards its center. That is what is 1 kgf. It's nothing but it's another unit for weight. It's like, it's basically another, in other words, it's nothing but weight itself. All right, now to answer the second part of the question, if the boy, I'll just draw a seesaw first. All right, okay, so there's the seesaw is balanced in the middle. A boy of 30 kg, 30 kg, 30 kg, he's sitting 2 meters away from the middle. 2 meters away from the middle. Where should a boy of 40 kg sit in order to balance it? That is the question. So again, clockwise moment is equal to anti-clockwise moment. So clockwise moment is nothing but we'll just take it as 40 into x. 40 into x. Anti-clockwise moment is nothing but 30 into 2. So either you can do it like this, people. So again this will save a lot of time. So remember the principle of moment. Anti-clockwise moment should be equal to anti-clockwise moment in order for you to see the balance. So again, 40 x is equal to 60. So x is equal to 60 divided by 40. 0 0 gets cancelled. 2 2 4 2 3 6. Which is nothing but 1.5 meter. So the answer to the second part of the question will be 1.5 meter. You should be sitting. This person with who's 40 kgs away, whose weight is 40 kgs, should be sitting about 1.5 meters from the center. Now to answer the third part of the question, what is meant by the term moment of force? Now I don't have space to write, so I'm going to go to the next page. So yeah. What is meant by moment of force? The torque is what is called as moment of force. What is moment of force? It is nothing but the turning effect that is caused when you apply a force on a body which is pivoted about a point or which is fixed at a particular point. So it is the turning force. The turning force that is created, the turning force that is created when a force is applied on a body which is pivoted at a point, which is fixed at a point, which is fixed at a point. I know, it's like doctor's prescription. I understand it. Or don't take this and go take what to say. Don't take it to the nearest store and all that. It's just that my handwriting is very very tidy. All right, so that's why you can't understand it. That is the reason. It's very tidy. It's very clean. That you might have to go, once you reach your PhD and all, then you might be able to understand. So until then, it's okay, happens. Alright. Second part of the question is, if the moment of force is assigned a negative value, then what will be the turning tendency of a force? Will it be clockwise or anti-clockwise? If it is negative, people, it is going to be clockwise. Remember this, negative is clockwise, positive is anti-clockwise. So this is a 5 mark question that took hardly 3 minutes to solve. I don't think it even took 3 minutes just to write it. It would have, because my handwriting is so clean, it would have taken longer, but it does not take more than 3 minutes. 5 marks, people, 5 marks in your pockets. That is what this question means. 5 mark. That could mean a lot. So yes, people, this is the answer for the first question. This is the answer for the ninth question. So 1 kg is the force by which Earth pulls an object of 1 kg towards itself or towards the center. If the distance is x, then using the principle of moment, clockwise is equal to anti-clockwise. So the answer will be 1.5 meter. The turning effect of force acting on the body about the axis is called as moment of force. And yes, it is clockwise, right, guys? So that's it for the sprint X. We did force, torque in couple, equilibrium in principle of moment, center of gravity, uniform circular motion, and centripetal and centrifugal forces. All these questions are done. This is your homework. Let me know who gets 2019 board exam question. Let me know what is the answer in the comment section. Let's see who will be the homework rockers in the next sprint X. So before the next sprint X is out, make sure that you give the answer in the comment section. The question is, define what is couple. State the SI unit of moment of couple. Let me know what is such an easy question. Define couple. What is the SI unit of moment of couple? Let me know what is the answer in the comment section. 2019 board exam 2-mark question. Go ahead and solve this, guys. That's it. This is the current session. The next session will be out on 9th. So before that, make sure that you give the homework as well. And the next session will be on work, power, and energy. So until then, take care, people. I hope you found it helpful. The link is also given in the description as well as the pinned comment section. Amy Pro is my discount coupon code. That's it. All I have to say is this, guys. I know that a lot of you guys are anxious about your dates not being announced. Some of you guys are feeling like, sir, why is that ICSE is giving less importance to CBSE? I understand it. I've been there. So all I have to say is this, people. It's not that you're being ignored. The time will come when your dates will also be announced. But whether it's announced or not, whether the dates are coming out today or tomorrow, it does not really matter much, because what's more important is how well you're prepared. Even if the exam is tomorrow, you should have the confidence that I will be able to score at least 90%. And that is what we are here for. And that is why we've been doing it from the start, to help you guys do better. So all I have to say to you guys is this: don't stop. Don't pretend like your exams are going to be postponed. Don't pretend like you have a lot of time, because you don't. Make sure that you give your 100%. Does not matter even if it is solving 5 questions. If you feel like you've done it, if you feel like you have put in the effort, that's all that matters. So make sure that you have a timetable, give your 100%, and any help that you need, please feel free to reach any of us, guys. We are all here for you, people. So that's it from my side. Thank you for joining. I'll catch you guys in the next one. I'll see you guys in the next session with work, power, and energy problems of Sprint X itself. So until the next time we meet, this is Anoop. Adios, people. Do not forget to like, share, and subscribe. I'll catch you guys next time. All right. See you soon. Bye bye.